Welcome to Science Modernizers. Welcome to this video. Today we are briefly going to see how to use a multimeter. So let's get started with the video. To begin with, this is a typical digital multimeter, in which most of the multimeters you might see may not have these internal properties within, all those signs inside. So beside, I'm going to present a multimeter which is typically seen or used in laboratories, in our laboratories. So this is another sort of a digital multimeter. So no matter the one which you meet, their functionalities are similar. Now today we are going to see we are going to focus basically on how to interpret the scales. That's the scale, and likewise we are going to focus how to interpret this. Now we are not going to see everything, but we are just going to touch that which is necessary for you to understand. Now you see, as the multimeter generally is an electrical meter which permits us to measure several electrical parameters. For example, we can measure voltage, we can measure current, we can measure resistance, etc. Now at this stage here we have a scale. Now I'm going to focus on this since it is well divided, so but both of them will work in the same manner. Now when we look at this multimeter on my right, that's this multimeter. We are working with a yellow multimeter. The black multimeter is the same, but we are going to work with this since it is well divided. We can see the DCV, ACV, DCA, and so on. So this means direct current voltage, this alternating current, that's direct current. So yes, we will measure current either in amperes or in milliamperes. Now as you see a multimeter, the first thing we are going to realize is you are going to see some plugs here, 3 plugs. Now those 3 plugs are used to connect these wires. Now this wire, we can take the red wire. The red wire can be connected. We can connect the red wire in the COM part, or let's say we connect the black wire. Let's take the black wire, let's remain fixed on the COM part. Now the red wire can be connected either in the VOMA part or port, or the 10 amperes DC port. Now if you are dealing with very small currents in the order of milliamperes, it is more preferable that the red should be connected here. If you are measuring currents which are higher than which is higher than the order of milliamperes, then it is preferable to plug here. But notice the black remains on the same spot. I hope it's clear. The black remains on the same spot, so we keep the black on the COM port, keep it there. Then here we have the black, it remains there. Then we can now vary the red depending on the order in which you want to measure our respective currents. Now if you have to measure resistance, you leave it there in this spot. Okay, so let's now go. When a multimeter is given to you, when it's vertical like this is off, it means nothing is being displayed on the screen. So in other words, if you want to switch it on, you simply turn the multimeter, you simply rotate it to the direction which you desire. It will automatically come on and will be giving you 0 readings as values initially. So you are going to see a display of series of zeros depending on the precision. Now this definitely also gives you the precision, but this value is on the screen is not a reliable one. So when you turn to a given port, the value which you see appearing here, 000, is the precision of that particular scale of measurement. Now when a multimeter is given to you, the first thing you do is to verify if the multimeter is functional. And to verify if a multimeter is functional, it suffices for us to test for continuity. Now we are going to observe this little icon which coincides, which resembles that of a speaker. Now what you do is you turn this head in such a way that it points here. It points here. And so you now take these two terminals when they're already connected to your port. You take the two terminals, you join them together, and it is going to produce a sound. It means that the multimeter is actually functional. Is that okay? So always test for continuity first before you start using your multimeter. Now we are going to talk about some respective regions which you see. Here we have the DC voltage region. Here we have the direct current, and here we have the resistance. So we are going to focus on those three parts, more especially on those three parts. Now when our blocks are the way they're supposed to be, here we have the black, either the red here or there. Now when we tune to DCA, when you tune here, your multimeter is no longer a general meter, but your multimeter becomes an ammeter, because at this stage it is measuring the direct current. It is measuring the direct current. So what do we see? It means that at this stage, once you turn your multimeter and it is in the zone of DCA, it stops being a multimeter. It now becomes your ammeter, because it measures the current at that time. So if you are measuring currents and you realize that the readings, if for example, let's say I have a battery, or let's say I have a cell, or let's just say battery. Let's say I have something like this. And I want to, for example, connect a resistor. Get it? And now I want to measure the current which is flowing through that resistor. So I will have something like this. Let's see, here I have a resistor, and I connect, let's say I'll connect my ammeter somewhere here. That's my ammeter. Okay, now a certain current leaves the source I and flows through the resistor, and then we are going to record it by the with the use of the ammeter. Now as we have tuned in this zone, our multimeter becomes our ammeter. So when you draw the circuit diagram, what you do is you simply replace this multimeter in the place of this ammeter. You place it in that position. So what do you realize? It means that this ammeter, which is our multimeter in this case, one of the ends should be connected to the battery, or to the cell, yes, the battery that has been given to you, to your power source. And you see the one of the other ends, let's say the black, should be connected to one end of the resistor. I hope you are getting the sense. And your resistor now should be connected to the other end of the battery using connecting wires. And you might also be given crocodile, how do they call that thing? These crocodile clips in order for you to fasten your wires together in order to ensure good electrical conductivity. They are always given. Now when current is passed, as current flows and your multimeter is connected as shown in the circuit, what happens is, if the reading on the screen is 1, it means that the range in which the current which is flowing through the resistor does not belong to the port where your multimeter is. Let's take a typical example. So assuming that you have connected your multimeter to the circuit, and then you switch, for example, to 200 milliamperes. So this your man is somewhere here, 200 milliamperes, something like this. So he's there at 200 milliamperes, and what you realize here, you see that your screen displays 1. Please, the reading is not 1. it simply means that the current you are measuring is solely greater than 200 milliamperes. So you have to turn the port. I hope it's clear. So in other words, imagine or suppose that you turn this and it is pointing in 20 milliamperes. So if you get no reading, it means that current should be greater. So you have to swap and turn to the other. If it still shows 1, you turn to the other until you have a reading. So as soon as you have the reading, you make sure you check where the reading is. And as I said, when current is already too high, it is more preferable to place the other port in the 10 ampere zone. Okay, so that's how it works. The same thing applies for voltages. Once your multimeter is turned to become at the level of the DCV, it stops being an ammeter and it stops being a multimeter. We now call it a voltmeter. So it is there to measure voltage. So the same principles apply. If, for example, you are given a battery, and you are asked to measure the EMF of this battery, and then you take your multimeter, the multimeter is connected normally, so it should be connected to the COM port and to the V ohm milliampere port. So what you do is you take one of the terminals of your meter, you connect on one side, you take the other terminal, you connect on this side. Get it? So it should be something like that. So here you have your voltmeter. Now what happens is, if for example you turn and you see that at the level of 20 millivolts the multimeter reads 1, it means that the voltage of this battery is greater than the other, or is greater than 200 millivolts. Now you turn again. If it is on the 2000 millivolts and it still reads 1, it means that it is greater than 2000 millivolts. You turn to 20. If still you have no reading, you turn, and so on and so forth. But typically in the A level, your reading should be found here. Yes, it should be found there for the batteries and cells that we use. Most of them, when connected in series, they can give us 6 volts and so on and so forth. It just depends on the type of cells that are using. So that's how it is. So I hope you are getting the sense. When you turn this to any of these regions, it stops being a multimeter and becomes this meter. So that's the ammeter, this is your voltmeter. Now when you turn to the zone of resistance, it becomes your ohm meter. So if you have a resistor and you want to measure the resistance of the resistor using the multimeter, you first of all start by turning this to the resistance zone. Let it become an ohm meter. Then you take one of the terminals and connect on one side, and the other terminal is connected on the other side. Now you switch. You start. It's always advisable to start from the smallest and you start going up. Always start from the smallest. So we can start from the 200 ohm. If you have no reading, it means the resistance of that resistor is greater than 200 ohm. So you swap to 2000. If you still have no answer, it means the resistance of that resistor is greater than 2000. You swap to 20k. That's 20,000. It means if you still have 1 shown here, 1, it means that it's not in that order. So that's typically how it functions for all the respective regions. That's how it functions. So it is always advisable to begin from the smallest, then you start switching to larger units. Get it? So if you want to measure current, it's better you switch. You start here. When you see 1, you go there. When you read 1, you go there. If you see a reading different from 1 here, you can collect it. And don't forget that the units are here. That's 20, in the order of 20 milliamperes. This is in the order of 200 milliamperes. So maybe if you are here, you are going to have something like 203. So that 203, respect the precision which is written. So if it is when you turn there and you see something like 0.00, it means the precision or your reading should be written as such. Yes, exactly. So if you see, for example, 00.0, it means your reading should be written as such. So if you have 203, you should write it as 203.0. So respect the precision of the multimeter when you turn to the zones. So each time you turn to the zone, remark how the digits are written there, and the digits written there will be in the orders of 00 first when you have not connected anything. So switch it and see when there are zeros and observe the pattern. So that gives you exactly the precision of the instrument or of that particular zone, so that when you're writing down your values should respect the precision of the meter. I hope that's clear. So that is how you use a multimeter. So in summary, we can use a multimeter as an ammeter, as a voltmeter, and as an ohmmeter. Also, it can be used to measure AC voltages, but that is not our concern. So our concern was to see how to use it as an ohmmeter, a ammeter, and voltmeter. And don't forget, your plugs can vary. So when the black is fixed on the COM plug, then if you are measuring little current in the order of milliamperes, the red should be here. If the current is too high, you put it in the 10A DC. Confirm. If you are measuring resistances, you can leave it there, and voltages, it can remain there, no problem. So that is how you use a multimeter typically. So connecting it now to your circuits, is no longer a problem. So imagine you are verifying. Let's take something very simple. Let's draw a very simple circuit. Let's draw a very simple circuit. No, sorry. So exactly how you are seeing this, the picture of this circuit, if you want to represent it, it simply means your cells are given to you. Your cells will be like batteries in your remote control. Those two batteries in your remote control, how they are. So they will just exactly how that port of your remote control is, that's how it might be. Then you have now some wires going out which can permit you to connect them. So you have some connecting wires outside, exactly how your remote control which you use in your TV is, that's how they are. So but the batteries might just have bigger sizes and so on and so forth. Now as we have it as such, now you see this is it, this is it here. Now our ammeter becomes the multimeter. So you simply place the multimeter in this place. What is happening? You see that one of the connecting wires leaves the ammeter to the battery. So it means you simply take one of these and you connect. That's just what it means. And likewise, the other side is connected to one end of the resistor. You take the other side and you connect to the other end of the resistor. That is simply how it functions. So if you know your circuit diagram in your head, always try by writing or by drawing your circuit diagram somewhere on the rough sheet, even on your table where you are working. Just draw something rough, then you place the instrument the way they are supposed to be, and then you do whatever you were asked to do. Now in the case of a mainstream, they will tell you where to put your plugs, they will tell you where to indicate a plug, or they will tell you where to put this. They will tell you exactly where you are going to tune to in order for you to measure your voltages or currents. So they will tell you exactly where you're supposed to tune to. So be very attentive. If it is a mainstream, they will give you instructions on how to use even this and how to connect it so that you can be able to collect your data fast. But as a station, they are the one to know. So you have to take and do everything that we have said. So this brings us to the end of this video. Thank you very much for watching. Please do not forget to like, share and subscribe. See more 430.